Welcome to this video where I will demonstrate the functionality of my application irisChatGPT. This application leverages the functionality of one of the hottest Python framework, LangChain, which is built around a large language model. And this application is using Intersystems embedded Python functionality in objectscript, and it also contains Streamlit web application, which is another open source Python framework to create data science and machine learning web applications. So this is our application, and it's built on the LangChain, which communicating to OpenAI. And here we have Streamlit application, objectscript reference. The PDF is already saved in this application in the vector database. Then we have SQL database chain functionality. We have option to just create this chat GPT based on our documents, and we can communicate this web search engine and the Wikipedia as well. So this is a layout of the web application. These are the features of the applications. So we have Intersystem objectscript reference. The PDF contains all this information. Is already saved as a vector database, so we can chat with it. And then we have this Intersystems Grand Prix contest. This the existing one, so we can also chat with it. We can answer question over cache database, and by using SQL database chain we can create our own chat GPT. We can communicate with OpenAI, and we can search Wikipedia, search on the internet by using DuckDuckGo general search engine. And we can generate Python code by using Python REPL LangChain functionality. And we have this Streamlit web application where we can also have a web interface to do all these tasks. Before continue, let's see how this LangChain is basically the flow of the LangChain. So this is article. So here the details, and this is the LangChain structure. Basically it contains mainly the models, the LLMs and chat models and text embedded models, and we have prompts which we are sending to the this LLMs, indexes, we have chains, we are sending multiple commands, just combining and sending to this LLMs. We have memory to save the transaction and then communicate to them, and we have agents that make decision, takes an action, makes an observation about what has done. So this is the flow, how the application is working. The user asked the question and it went to the LangChain. Then LangChain sent this question to the embedding model. So this embedding model convert it to the vectors, this text to numbers, and then it's returning back to LangChain, and this LangChain send this vector data to the database where we already saved, we already build our model. Then it's return the top k approximately nearest neighbor vectors knn to the LangChain, and then this LangChain send the question and all these knns to the large language models. These are some of them. So we are using OpenAI here, and here we are using this Chroma database. So this large language models done their process, and based on all this information, this model returns the answer to LangChain, and it's returned back to the user. So this is a basically flow of the LangChain. So back to the application. So this is application. We can use Git, and then we can use Docker Compose, and we can also use ZPM to install this application. So I already Dockerized this application. I already run Docker Compose, and also so this is an important part. We need to get Open API key, which we can take it from this Open AI official website. Just we have to navigate this page, and then just create a new secret key if it's not created, and then we just copy that one. And here we are using Docker Compose in the command prompt to connecting to our prompt to the terminal. So here then we are making a new instance of this class. This is irisChatGPT. So this is basically the main class. So this is extended from the register object, so we can make it use the new function to create a new instance. So here we are getting the new instance, and then we are setting the API key. So this is the same API key which we created here, so we can just take it, copy and paste it here. So when it's done, so then we can start to use the functionality of this application. So first of all is we are using the chat with Intersystems objectscript reference. So this is a reference, so we can ask any question about it. So for this we are using this function irisDocs, which is the so this is a function basically irisDocs. So we are passing the query. If for example we are asking give me details of this base function with the syntax, so we are just let me clear the screen terminal. Okay, so we are saying write whatever is returned, it will write on the screen. So chat.irisDocs, and this is our query come here to the function. So this is a LangChain, it's taking the Chroma database, is using the embedding from the LangChain model, and this is the LLMs. We're using OpenAI. So as I explained here, so here we are using this embedding, then we are using database, and then we are using LLMs. So here we have this is a database, this is embedding, and this is the LLM, and this is a LangChain memory and LangChain chains. And this I am importing iris to take the this API key which is stored in a global. So here I am getting this key, and here I am assigning to this variable. So after that I am getting this embedding by using this function, and this is a database directory is saved in this environment in the vector DB. In the manager directory we have Python folder, and then there is a folder vector DB, and we have vectors. So this is a folder basically where this Chroma database is saved, and we are just referring to it. So this is a vector DB. We are chroma. We are just taking this data, and then we are using this buffer memory, and then after that we are using this LLM. To this LLM we are passing this all the vector data and the memory, and this is a temperature equal to 0. This is just to see the variance. So this temperature regulates and the randomness of this model. So here the query we are passing to this one qa.run. So we are just giving the query. So this model already have all this vector database. So after that it's making the decision, this LLM, and returning back the result which we are displaying here. So this is a flow how we are reading the data from the vector database, and how the LangChain basically the normal flow. So let's run it. So we are calling this function that is doing the processing, is returning back the information so about the function. So next we are using information about the contest. So just I am copy pasting this here. Okay, so we are saying iris contest, give me prizes and nominations. So again it's using this function iris contest. So the same thing here, only the difference is the database folder is different, where I already saved this information as a Word document. So enter, and it will return the information. So I'm saying give me the prizes and nominations. So it's saying expert nomination, the first prize, second, third, and then community nomination. So these are the details. So then next we are using this. So here we are using this irisDB to answer question over cache database. Let me copy and paste here. So this irisDB again it's taking the OpenAI, and then it's taking the SQL database and database chain, and it's also taking the prompt template, and here we are getting the API key, and this is basically the template we are using in the prompt, and this is a connection to the database, and this is we are calling LLM OpenAI, and then we are just passing this query to this SQL database chain, and it's returning back the result. So let's run it. We are saying give me total tables. So it's running the chain. So this is a query. So this is a query basically, and then it's returning the result, and these are the total tables. Okay, so next next we are creating our own GPT model. So for this we can just ingest any file. So in our case I already have this PDF file. This is basically defining and using classes. So let's me navigate. So this is all the PDF files. So this already I have in the repository. So this file is this file in the folder below the repository already contain. Okay, so for this so copy your document to this manager directory and then PDF data folder. So I already have this file. This is the Docker and this is the in the user iris's mgr and PDF data. So I have this PDF file already. So let's ingest this file. Okay, hit enter. It might take some time based on the size of the document. Basically what is doing, this is calling this function. We are giving the path, so it's so then it's taking the embedding and then the PDF loader from the document loaders. So it's taking the embedding, taking the file, then is splitting this to get the extension, and basically here is then it's loading to the PDF, the loader, and then we are using the document equal to loaders.load. So then it will load the files to the documents, and here we are using the text splitting. So it's making the chunk size 1000, so it just break this PDF to different sizes. Then we are using here chroma from document. So here we are using this embedding and then converting these chunks to the this vector to the vectors, and then saving to this directory, which is the personal directory in the here in the repository. And then we are using this function persist to save this database. And so here the file uploaded successfully. So let's use this. So I have already one command here, so let me copy. Okay, so I'm using this function personal GPT. So personal GPT is almost same like irisDoc and irisContest, but the difference is the vector database folder is personal. So this is a personal GPT, and here we are using personal folder. So let's run it. So I'm saying give me the details of objects and properties. So object are entities and properties. So these are the details. So next we can use open iChatGPT and GPT directly. So just we have to call this. Let me. So this is we are saying write. So whatever the value is returning this function OpenAI. So this is a function OpenAI. So it's checking the chat open AI, and then so it's using this model. This is a GPT 3.5 model, Turbo 0613. So now in this case, this is our database and all the model which is already trained. So again we are using LLM. We are using this function, and it's making all this prompt and all these details, and then here we are running the query, and it's returning back the result. So basically it's calling using this model here. So this is a model name equal to model. So this is a data trained model where it will take the result. So I'm saying chat OpenAI, give me details of Intersystems. So it's return the details. Let me just So these are the details about Intersystems. Okay, then we can use this Wikipedia here. So let me copy this. So the Wikipedia, we are using another library for this. So this is a Wikipedia. We are importing the utilities from this Wikipedia, and we are just calling this run function to get the result back. So I'm saying Wikipedia give me details of LangChain. So okay, so it returns the LangChain is a framework designed to simplify the application. So these are all the details it returns. So same way we can use this search engine DuckDuckGo. Let me copy this command. Okay, so this DuckDuckGo, here we are calling this again, importing this this DuckDuckGo functionality from the LangChain tools. So this was from the utilities and this is from the tools, and then we are just calling this run method. So let me run. We are saying what is the capital of USA. So it's checking and it's returning Washington DC, and along with these details. Okay, so next we can use Python REPL LangChain functionality to generate Python code. Let me copy it. So let me run it. Okay, so I just clear the terminal. So here we are saying chat Python REPL, and just we are saying write a function to check if 11 is a prime number and test it. So this is a function. So it's again checking the LangChain agents, then Python tools and OpenAI, and taking this API key, and then here is calling the OpenAI, the LLM, and then it's executing this agent. So let me run it. Okay, so it's entering the chain, and so this is all the detail. So I need to write a function. So this is a function, and so I need to test the function. So it's testing. So it's true. I know the final answer. So the 11 is a prime number. So this is the Python REPL functionality. Okay, so this application also contains this Streamlit web application, so which can be run here. It's running on the port 8501. So I am already running it here. So I already passed the API key which is required. Okay, so let me ask a question. Intersystem objectscript reference we are using. So let me see what function we are using. I mean, what question we asked before. So here I'm asking give me for loop syntax with examples. Okay, so give me for loop syntax with examples. So what it will do, it will call the function. It's in the Python we already have one file here. This is a Streamlit application here. So again from here it's calling this is a basically application. This is our application, and here we are here I'm saying if Intersystem objectscript. So this is a user question, and in the user input so this is a user input. If this is Intersystem object reference, then here it's calling a response. So here is taking the database from here. So basically this is a database is taking from the is taking from here. So we are calling this vector store is equal to irisChatGPT doc loader. So this doc loader basically returning all the database whenever we are initiating this Streamlit application. So I'm getting these details from doc loader, so which is here. The doc loader is this one. So what is doing is taking the vector database from this folder vectors, and this is in case of contest. So it's returned back to the Streamlit application. Okay, so it's already returned the result. So give me for loop syntax with example. So it's returning me the details. So this is a for loop, and this is the with parameter, and this is with some examples. So same we can do here. We can use Intersystem for the contest question, and here we can also use a personal chat GPT. So we can browse here any file. Just browse the file. So desktop I already have some PDF files. Let me select one of PDFs. So here I have in here I have, for example, this file AE Python. Let me process it. So this AE Python file is basically this file using embedded Python. So it will just take all the details and save in the database, in the vector database. And after that, let's once it's finished, okay, so it's done. So we can ask the question. So let's ask a question here. So this is a file. So let's take this, for example, just copy and paste here. Just convert to the question. How to start the from terminal and say with examples. Okay, so it's running. So this is a question. Okay, so this is what is written. So the startup Python shell from terminal, you can follow this step. Open Intersystem terminal session. Okay, then here is example. So this is to running the shell and the Python shell. So okay, it took this command, and then I think the same, yeah, the code, and it's taking this information as well, yes, and also some details. So this is how we can just use any document file, PDF, text, Excel, even CSV file. Even we have a lot of other types as well, and we can just build our own ChatGPT model like this. So that's all. Thanks for watching.